Okay, so for 7.6, we're going to be looking at a normal distribution. You need two things before you start looking at these notes. Make sure you have your calculator, and make sure you have your formula sheet, because we're going to be using the tables on the second page. So make sure that you have this handy in your calculator. So if you don't have it, pause the video, go get it. So 7.5, we looked at common discrete variables with geometric and binomial. 7.6, we're going to look at the most common continuous probability distribution, which is the normal distribution. So the graph of a normal distribution is sometimes called a normal curve or a bell curve. So normal curves are mound-shaped and symmetric. On any normal curve, the points of inflection are found one standard deviation above and below the mean. So we sort of touched on this before. You've sort of seen this before. This is like mu. This is mu minus 1 sigma. This is mu minus 2 sigmas. Oops, plus. This is mu minus 1 sigma. This is mu minus 2 sigmas. So we've done that before when we had like the 34, 34, 13 and a half, that kind of stuff. So it can be described just using two numbers. The mean, again, we use mu, and the standard deviation, which is sigma. So the center and the spread. So like any other continuous distribution, the total area under the normal curve is always equal to 1. Thus, the probability that x falls within any particular interval is the area under the normal curve at that interval. The probability x takes on a specific value is 0. Again, there's some calculus involved. We just skip it and do 0. Unfortunately, it's very difficult to find areas under the normal curve by hand. So we're going to need to learn how to use a z-table, which is why you need your formula sheet, which gives the area under the curve for many different intervals. So recall our z-scores that we learned from chapter 4, I think. Tells you how many standard deviations an observation is from the mean. So the standard normal curve is the normal distribution with a mean of 0 and a sigma of 1. So when we're using the standard normal distribution, it's common to use the z to represent the random variable instead of x. So if x is the length of a newborn baby, the mean and standard deviation of newborn babies are 19 inches with 1.2 inch spread. Sketch the distribution and shade the area that corresponds to x being greater than 21. So if I have my curve, that's a slightly skewed curve, but let's pretend. 19's in the middle. And we go up 20.2, 21.4, 22.6. Normally we go up 3. We go down 3, 17.8, 16.6, 15.4. X being 21 would be like right here. So the probability x is greater than 21. Now, when we did this before, you couldn't do that because it's not one of the nice, you can't break this down to 34, 34. It's not one of the nice z-scores. So we don't know what this is. So that's what we're going to learn how to do today. So what we use is we use the normal table on the next in your formula sheet. So what we're going to do, you basically locate the row with the sign of the z star, or the z that you're looking for, and then it tells you underneath. So I'm not going to read this, I'm going to just kind of tell you as we go through. So find the probability z is less than negative 1.76. So if I have a z-score of less than negative 1.76, I'm going to draw, a normal distribution, make it nicer. So we have 0, negative 1, negative 2. So I'm looking for this, less than negative 1.76. So what I do, take your formula sheet, and you want to go to negative zoom in. So I'm going to look for the row negative 1.7, and then I'm going to look at the column 0.06, which would give me my 100th place. And then I'm going to use my fingers. So the probability I have less than a negative 1.76 standard deviations is 0.0392. Okay. Now, what's the probability I have greater than negative 1.28? So again, if I draw this, 0, negative 1, negative 2, I'm looking at negative 1.28, I'm looking at greater than. Here's the thing with the table. The table, if you look at the sketch at the top, only gives you less than. So the table only gives you lying below your z. So if you're going to do a greater than, you have to do 1 minus, because you know the whole table adds up to 1. So I'm really going to do 1 minus the probability z is less than or equal to negative 1.28. And remember, with continuous, less than or equal to, they're the same thing. So I'm going to go to negative 1.2, just over here. And then I'm going to go to 0.08, and I get my probability of 0.1003. So 0.8997. Which makes sense looking at sketch. What's the probability I get a z-score less than or equal to 0.58? So 0, 1, 0.58, I want less than or equal to. So I'm going to go to the positive side. So if you take your table and flip it to the next page, there's the positive side. So you want 0.58, 0.7190. What's the probability I get a z in between negative 1.76 and 0.58? So 1.76, so in between. So now in between, what you're going to do, again, the formula sheet only gives you less than. So I'm going to take the probability z is less than 0.58, and I'm going to subtract the probability z is less than negative 1.76. So I'm basically taking less than this whole thing, subtracting out that little guy, and I get the in between. So luckily we already have these done. So 0.58 is 0.7190, 0.0392, 6798. So you always got to think about, now here's the only mistake people will make. They will subtract these two numbers and find that probability. You want to find the probability first, then subtract. Okay. What's the probability that z is within 2 standard deviations of the mean? So you want the probability between negative 2 and 2. So I'm going to take the probability z is less than or equal to positive 2, and I'm going to subtract the probability z is less than or equal to negative 2. So positive 2, I'm looking at 2.00 is 0.9772. Negative 2, again, I'm looking at negative 2.00, 0.0228, so 0.9544. So if we think back to chapter 4, remember the 68, 95, 99.7 rule. This is more accurate. So the table is more accurate. This is more of an estimate. This is more accurate. So that's why it's a little bit, there's a couple more decimals. Okay, let's try going the other direction. So the other way I can do is basically I can give you a percentile and ask you to find the z-score. So what z-score do I need in order to fit that percentile? So it's like we say it's called finding z-star. So what z-star do I need to find to get 0.1? So this is asking for basically, remember we talked about percentiles? This is basically the 10th percentile. So what z-score do I need to get the 10th percentile? if you think about it in terms of a picture, what it's asking for is what z star here do I need where the area under the curve is 0.1. So what you do is you go to your formula sheet, flip it to the negative side, just so you know, and you want to look inside the table, and you want to get as close to 0.1 as you can, and then look at the z-score. So if I get as close to 0.1 as I can, and I want to try and zoom in so you can sort of see, 0.1 right here, 0.1003 is, I think, as close to 0.1 as I can get. So then my z-score there would be negative 1.28. So my z-star is negative 1.28. So you want to get as close as you can to that number and then look at the z-score. So what's the probability? Now here, be careful, this is z is greater than. So I'm actually looking at a number up here where the top 30 percentile. So this is like the top 30%. So really what I'm going to look up, because it's a less than, I'm going to look up 0.7. So I'm going to try and get as close as to 0.7 as I can, because that'll tell me the z-score that would be greater than. So don't do 1 minus. Well, you are going to do 1 minus, but. So I'm going to be in the positive side. Is basically the positive side is more than 50, the negative side is less than 50. So I want to get as close to 0.7 as I can. Let me see if you guys can see that. So I get 0.719, 7019, 6985. It almost looks like it's right in the middle of these two. So I'm going to say z star is about 0.525 instead of saying 0.52 or 0.53, because it almost looks like it's exactly in the middle. Find the z and negative z that separate 85% from the extreme 15%. So if you think about what it's asking, you have your middle 85%. It's asking for a negative z and a positive z. That basically this is 0.075, 0.075. 7.5 on each side. So what I'm going to do, I'm going to look up 0.075, or I could look up 0.925. 0.925 is the positive z. It's 0.85 plus 0.075. The nice thing about the bell curve is it's symmetric. So if I look up this one, it's a negative z, it's the same one for the positive. So if I want to get, let me go back to my negative side, 0.075, can't find it. Oh, there it is. 0.075 right at the top, 0.0749, so negative 1.44. So my z star would be negative 1.44 and positive 1.44. Or you could write plus minus 1.44. Okay? So what z value makes up the most extreme 5%? So again, you're looking at the middle 95% and then 0.025 on each side. So what I would have students do in class is say, okay, now look that up in your table and let me know what you get. So try that on your own. You may need to pause. See if you can figure out, you either want to look up 0.025 or 0.975. And what you should get is plus or minus 1.96. If you looked it up correctly. So let's try some with an actual example, because a lot of times we're not going to be dealing with just z-scores. You know, every problem in this class is really a story problem. So we're going to use those techniques now. We're going to add one more step to it. So we're going to use things we already know how to do to put it all together. So X is the score on a statistics test. The mean here is 75, standard deviation is 8. In this case, we would need to convert any scores on the test to a z-score. Again, your z is always X minus the mean over the standard deviation. Now that's not on your formula sheet, but you can kind of see it here. We'll get to this in second semester, but statistic minus parameter over standard error. Okay, so find the probability a student scored less than a 90 on a test. So probability X is less than 90. So again, remember with continuous, it doesn't matter if it's less than, or equal to, it's all the same thing. So your first step is you got to find a z-score. So I'm going to find the probability z is less than, I'm going to find the z-score. 90 minus 75 over 8. Oops. So I get the probability z is less than 1.875. So really, I wish this was a nicer number. What I'm going to look up is I'm going to look up between 1.87 and 1.88. I just don't feel comfortable rounding up, especially if it's 0.5. So if I go to positive 1.87 and positive 1.88, I get 0.9693, 0.9699. So easy to take the average, 0.9696. So we're just adding in that step of finding the z-score. Find the probability a student scored greater than a 72 on the test. So X is greater than 72. So again, your first step is to find the z-score. Notice when I'm doing my notation, I'm changing from X to Z when I find my z-score. So it should be greater than 72 minus 75 divided by 8. So Z should be greater than negative 1.375. Now, again, the table will only tell you less than, so I got to do 1 minus the probability Z is less than negative 0.375. So I'm going to do 1 minus, I'm going to go to negative 375 and negative 37, negative 38. 0.5557, 0.5, I can't talk. So 0.3557, 0.3520, 0.3539. And I'm going to subtract. Oops. 0.6462. And if you were a couple off, this one's kind of tricky because it's not a whole number. Usually on the quiz or test, I try to make it so that they're a whole number and you don't have to do this craziness. Find the probability a student scored between a 69 and a 91. So you want 69 less than or equal to X, less than or equal to 91. So we're going to find two z-scores. So probability 69 minus 72 divided by 8, less than or equal to z, 91 minus 72 divided by 8. So probability between negative 0.75 and 2. So now if you're finding it in between, again, you're trying to find between positive 2 and negative 0.75. So you're trying to find this in between. So I'm going to look up 2. The probability z is less than 2. And subtract the probability z is less than negative 0.75. The biggest mistake people will make is they'll subtract, they'll do 2 minus 0.75 and then look up that z-score. You want to look up the z-scores first, then subtract. So 0.9772, 0.2266, so 0.7506. Okay? So on your next quiz and on your next test, you're really going to need to use the formula sheet. So that's why we have our own for the quizzes and the test, because obviously you might be writing on these, but you really want to use that second page. And I'll show you how to do a lot of this in the calculator tomorrow.